The first talk today is Dr. Warwick Badgery from New South Wales DPI. So Warwick will be presenting one of his latest projects that is going to be supported by Food Agility, and it's kicked off about 3 months ago, and it's called Grazing Intelligence, Smart Grazing, Higher Profits and Better Environments. So hopefully we've got Warwick on the line here with us. You can come in. But this project essentially exists to create a pasture and animal growth modelling in both sheep and cattle to help farmers predict the availability and optimise the purchase of additional feed. By focusing on the animal performance rather than the feed itself, the aim is to hopefully improve farm profitability by up to 20%. So Warwick, the floor is yours, and as I said, I'll drop back in about 2 minutes to go. So, and I can see your screen is starting to share. If you'd like to turn your camera on so we can all see your face, that would be fantastic. And of course, unmute your mic.
There we go. Thanks, Mick. Thanks for that introduction. Today, I'm going to be talking about our project that's just starting with the Food Agility CRC about grazing intelligence. So what we're looking at is trying to deliver smarter grazing for farmers for higher profits and also to improve environmental outcomes. Today, I'll be presenting on behalf of the team, which has members of New South Wales DPI, Pasture.io. I'd particularly like to call out Igor Kardaliski, who is, I'll be presenting a lot of the background work that he's done for this project that has led into this Food Agility CRC. So one of the key things that we're addressing with this project is the problem that fruit producers are facing, that they're losing a significant amount of production just in how they manage their grazing animals. And from previous research, we estimate this loss could be as high as 20%. And that's just simply by where animals are grazing and identifying crucial periods where they're actually running out of feed in advance of that actually impacting on production. And that's in the extensive sheep and beef industries. One of the other key things that we've found from this background work is in this project is that producers don't have a lot of confidence about some of their grazing decisions, particularly as feed quantity and quality is declining. And that's one of the reasons for that is in these extensive livestock industries, they don't have regular feedback about how their animals are performing. They might only weigh their animals once a month or some of their breeders much less frequently than that. And so there can be often a shock when they do those measurements and realise that they've impacted on production a lot more than they'd realised. And one anecdote that was sort of given to me by a leading producer in the Orange area was when he got the first mob of lambs in for shearing, and then shearers commented how well they looked, and then they got the second ones in, and the shearers asked him, "What did you do to these? They're significantly lighter." And the farmer had no idea. He had thought that he had managed these animals exactly the same, and so part of this is that where farmers are really using a lot of subjective assessment around these decisions. And while we know that there's a lot of providers coming on board to give biomass estimates in this area, pasture biomass is only part of the story, which I'll sort of talk about today. So the value proposition that we've put forward for our project is that the grazing intelligence will improve the confidence of producers in making grazing decisions and add value to livestock businesses by providing clear animal performance recommendations and projections through farm management software. So what that means is we need to be able to predict that livestock performance. We need to be able to do that in real time. So we need management data that's coming back directly from the farm, and then we need to project that into the future so that the producers can make proactive decisions. So when we're talking about this improving confidence in decisions, there's a few areas that we've talked about that we want to do this. The most simple part of this on the farm is moving animals. And the first question is about when to move animals. Sounds really simple, but it's actually more complex than that, because we've got this dynamic relationship between the amount of pasture, which can limit production at times, the quality of that pasture, and then also varying animal requirements, which are based on the size of the animals, the breed, their physiological status, and all of these are dynamically shifting all the time. So at any point in time, there's some reasonably complex interaction that we need to deal with to be able to understand how an animal will perform. And once we understand how that animal will perform on a pasture, we then need to project that forward to say, well, how long will they perform at an optimum level or a desired level in a paddock? And if they're not going to perform at that level, where else on the farm can we move them to? And that might be to a next paddock in a rotation, but it might be to a totally different area of the farm because that vegetation in the next paddock is not, say, of a suitable quality for those animals to perform. The other key area is around prioritising limited feed on the farm. So when you're looking at sort of where should you put which mobs of animals, and then identifying sort of opportunities for either selling animals off the farm or providing supplementary feed to those animals so that they maintain the desired growth. And the aim about doing all of this is to earn the best sale results for the animals. We want to maintain the best production. And we know some sort of previous work we've done with this is if we can get 4,000 farmers sort of adopting this type of technology, then there could be the benefit around 156 million. With current livestock prices, that's going to be considerably more than that. Just a bit of the structure of the project. Our first bit is around developing some machine learning models that predict livestock performance and pasture availability. Developing an API to display that data through Pasture.io, who are our commercial partners in this. Then there's some collection of animal data to validate the models, and then also the development of a business plan. We're going to have this key feedback loop for the science component, which is running the machine learning models against to predict animal and pasture data, and then collect that data to then compare and see how they perform, and then integrate that data back into the machine learning model process. So this just gives a bit of an overview of what the structure that we're setting up. So we've got some models that will be housed in some cloud computing with DPI that use satellite imagery, weather data, and management data. Then connected through the API to Pasture.io that will then display that information to a which can then be accessed by producers to then use that. And we can use that either in a research setting, which we're planning to do on our research DPI research stations. It can also be done with producers in a commercial situation as well. So at the moment, this is just a quick overview of where we're collecting data. These orange sites here were the sites that we initially sort of start building our models on and validating them on. We're just in the process of integrating some new data sets from these locations, and we're just setting up some further data collection where these blue stars are going at the moment, which will occur through the last 18 months of the project. The producer sites, we haven't identified individual producers to take part in this. We've got a lot who are interested, but we want to just make sure that we start the producer engagement in areas where we have confidence that the model's working. And so we'll stage that out based on where we have that level of confidence. Just for the rest of the talk, I'm just going to give you a bit, some background on some of the work that led into this and some of the model development side. It really developed up on from two grazing experiments, one that's at the Orange Agricultural Institute, which is a grazing management experiment, and another one that was at Penuara, it's part of the Evergraze trials. And these, I suppose what we've been doing with this trial data is one of the key things is linking that with the satellite data and weather data to try and predict the pasture performance and then the animal performance from that as well. So one of the key things has been, I suppose, the Sentinel imagery, which is obviously some low cost imagery that we can use for this, and that has become more frequent. And so this is just looking at the interval between passes of the satellite imagery and how that's changed over time with our orange grazing experiment. So where we started, we just had, we were just using Landsat 8. And then as the Sentinel satellites came on board, then the frequency between the passes became much less. So that gave a much better environment for trying to build in some machine learning with this data. The other thing that we picked up with the Sentinel imagery was a closer spatial resolution down to 10 meters from 25 meters. And then obviously there's other commercial satellites out there where we can get a bit further. And one that Pasture.io commonly use is planet imagery, which we'll do a bit of investigation with that to see whether there's any benefit from adding that into our predictive models as well. And then we're just using these as some of our input variables into our machine learning modeling. So what I wanted to show here was, this is just a graph that shows, a figure that shows some of our features that are involved in one of our dry matter models. And really what it gives is just a bit of an indication of what are some of the important figures that are coming out of this machine learning approach to the market, the information we're putting in. So the first one, and some of the most important ones are NDVI, which we know are very strongly related to biomass and used in a lot of other modelling approaches for biomass using remote sensing. And then we've got a lot of other factors that are actually included in these. And some of the things that we've got are things like a bucket rainfall graph, which I'll show an example of soon. And we just look at these on different intervals. So, and they get integrated at various levels. And so just here in this figure, if you're looking at the gain along the bottom, that's just the relative contribution to the model. And then the colours are just related to the frequency that they're actually included in that decision tree model. This is just a bit of an example. We use a very simple bucket for rainfall availability into this machine learning model. And this just shows an example of how that bucket represented the drought period that we experienced recently, sort of from 2018 up to when it broke just at the beginning of 2020. And you can see here that generally there's an increase in soil moisture through autumn in a normal year, with that sort of reaching maximum levels through winter, and then that being depleted through spring into early summer before starting to rebuild again. And so one of the clear indicators with this for the drought was that through that autumn period, rather than having an increasing trend in moisture, we had a decreasing trend. And rather than being close to maximum availability of moisture in our bucket, we were somewhere down around 20% full in winter leading into that next spring. So it was really helped us to predict or relate to the drought that really unfolded through that spring-summer period. So that helps to predict that to some degree. This is just showing some of the pasture components and just how the model has predicted those. So this is the grass component, is the perennial grass component. We've got a legume component that we can predict with a model, and then a weed component. So what these graphs show here, and this is just for one of our continuous grazing treatments, it shows that we've got this training period up to where the dotted line is, and then after this we've got a period where we haven't trained the model, but this was actually in our drought recovery period. So I just wanted to highlight that because we hadn't seen such high biomass and such quick growth, that was actually not able to be recognised by the model because we hadn't actually trained it for that period. But then we integrate that data and hopefully we can pick that up when that occurs in the future. And the same as we go into new sites, hopefully we start to train the models to perform at those sites as well. This is just another application of the use of these models. So this is where we're working with a PhD student at Sydney Uni, who had some GPS tracking collars on the animals, and then we worked with them to spatially improve and temporarily improve the pasture data available, so we could better make use of that GPS tracking data to see what was actually driving where animals were grazing and the performance of those animals. And so what this allowed us to do was to take our pasture measurements where we might only be collecting data sort of 6 to sort of 12 times a year, and then bring that into a format where we get better spatial coverage of that data across the plots that we were looking at, and also we get more regular measurements of that. And this here you can just see that for each of those grass components, we've got 2 grass components, a native and a sown, a legume and a weed, and these dots are just centered around a sentinel pixel that so that we can. So that's just another example of some of the models and what we've done to lead into this project. The last thing that bit of data I wanted to show you was some of the work we're doing around predicting performance. So there's a few key elements to this. I mean, currently pasture biomass is a big one that's been focused on, but we've got some quality estimates to that. We've got some composition elements to it, and we've also got how animals graze across an area. So that's animal behaviour, which can be related to the size and scale of the paddock, the vegetation, locations of water and things like that. So what this figure here shows is a number of different grazing events here where they've just been arranged from the highest performing period through to the lowest performing. And the other thing we've done with these weights is we've standardised them to this is sheep weights, 50 kilogram weather basically. And so what we see here is where we've got 0, there's been no weight change essentially of that animal. And the red dots here are our model predictions for these grazings that have been represented here. The black dot in the middle with error bars is the average, and then the variation of the mobs that were measured here. And so it does show that at the moment, just using a biomass model, we've got a degree of accuracy against predicting that animal performance, which we hope to build on with a few more of those elements being built into this modelling. One of the key things I'd like to show is what we're really trying to focus on is where this modelling, this point of inflection where we start to drop below a desired level of production. And we know that there's some error around predicting that. And so when we come to the actual part about integrating with producers and getting producers to use this, we need to sort of understand the error around this so that we can, we don't want producers to be able to have to understand the full statistics of what's, of how this data has been implemented in the error. But what we need to do is present that data in a way that we can say, righto, if you act now, you've got a good chance that you're not going to impact on production. If you act a bit later, then while the model still might say that you're okay, there's a lower chance of that actually starting to impact on production. And one of the other key things I'd like to highlight from here is while this work's sort of done on a standard animal, we've got lots of different animals that we're trying to mimic in this modelling framework. And so as an example here, this standard animal, if that drops below 0, if we were trying to say, looking at a merino weiner that was 25 kilograms, at that same point, that merino weiner might still be able to grow at something like 70 to 100 grams a day. And if we're looking at here at sort of that 20.2% of daily body weight, which is about 100 grams a day for a 50 kilo weller, that weiner might still be growing at say 200 grams a day. So we need to then extrapolate this data back to the standard animal, or the animals that are actually running in the paddock. So I just wanted to finish on making some points about what we're aiming for in this project. So we are sort of trying to remotely predict these livestock growth rates, estimate the grazing days in the paddocks for the producers, and also the pasture availability across the whole farm. We've got some accuracy criteria, which is, I suppose we're trying to make these obviously as accurate as we possibly can throughout the project. But then one of the key things is around this producer engagement. So we hope to get some producers trialing this product once we sort of have confidence in the output. So we'll do the initial work on the research stations to iron out the bugs, and then we'll start rolling out with producers. Initially, we thought we might try and work out how that improves their profitability, but we've realised that there's a lot of steps that are in between that, and the time frames might not work out for the life of the project. So one of the things that we've discussed recently is about using some of the producer engagement metrics in the Pasture.io software. So they're used to dealing with customers and getting feedback from customers. And so what we can look at is things like the number of times that a producer might use the software or access the software. Then they've got a mechanism for actually prompting feedback. And so was this data of any use? Did it meet your expectations? That sort of things. And we've got to work on the metrics there. So that's all I've got. We're looking forward to the next few years with Food Agility to try and see if we can get this concept to something that we can start using with producers. Thanks a lot.